Alrighty, today we're going to be having a look at some applications of trigonometry. So we've got a 2 meter wide tent, has a 3.5 meter guy rope, which meets the ground at 1.8 meters from the base. Calculate the angle to the nearest degree that the side of the tent makes with the ground. So in other words, we want to find this angle right here. So we're going to have to do a little bit of work. So first of all, let's isolate some of the different triangles that we can look at. So I'm going to draw this triangle in black. And the reason I want to draw it in black is that it kind of gives me a little bit more play on that particular shape. Alrighty, so I've just put a little X here, and now I'm putting an X here for this height. And you might wonder why I'm doing this, but if you're ever unsure, finding more information can never hurt. So then the other question is, what's this length down here? We know that it's 1.8 away from the tent, but then how far is it away from there? Well, it's 1.8 from here to here, plus an extra meter, because if you see, you can split the 2 meter in half and you'd get 1 meter on each side. So adding these two together, well, that's going to be 2.8 meters. And how can we find x? Well, we've got two sides and we want to know the third side, so we're going to use Pythagoras' theorem. So c squared equals a squared plus b squared. In particular, the hypotenuse, and we'll just call x a and 2.8b. So we're going to get 3.5 squared equals x squared plus 2.8 squared. Subtract 2.8 squared from both sides. And we're left with, on the left-hand side, 3.5 squared minus 2.8 squared. But we didn't want to find x squared, so we take the square root of both sides. We can just type that into our calculator, and we get 2.1 meters equals x. So we now know the length of x, which is 2.1. Well, now we have enough information to find the angle. So let's draw in a new triangle, and this is the triangle we're going to be interested in, the one I'm drawing in blue. And let's just redraw that triangle with all the information we know. We've got that this side is the same length as the side over there, but we don't know that side, so it's not going to be too useful for us to know. We want to know this angle, that's theta. This is a right angle. This is 1 meter from our above working out, and we just worked out that x, which is this side, is 2.1 meters. And we want to work out an angle. So this angle has the relationship that this one over here is the opposite, and this one down here is the adjacent. So we're going to be using TOA, tan. So tan beta equals opposite over adjacent. Substitute everything we know in. Tan theta is equal to opposite 2.1 over adjacent 1. But we want to find theta, so we're going to move tan to the other side, and when we do, it becomes tan negative 1. 2.1 over 1, which is equal to 64.536, which I'm going to round down to 5.4 degrees, since it is an angle. But it does ask me to calculate to the nearest degree, so I should round that up to 65 degrees. And there is my final answer. So you can see when dealing with more complicated shapes, you don't look at the whole thing at once. Instead, you draw a triangle in which it's got a right angle and enough information for you to work with. Alrighty, I'll see you in the next one. Goodbye.